Alright guys, welcome to today's class. So what we want to do in today's class is empirical and molecular formula. So that's our topic for today. But before we start today's class, I want to implore you to subscribe to our YouTube channel so that you can have access to interesting videos like this. Calculation is one of the things that make most students like it makes them like fidgets, and that is not something you have to worry about. And that's why we're here to solve questions like this that some students even find difficult, as simple as this question. So let's read the question. A compound contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molecular mass of a compound is 180, find its molecular formula. Now they give us the molar mass of carbon, that is 12, molar mass of hydrogen, that is 1, molar mass of oxygen, that is 16. Then the options are the following. Now, whenever they ask you to find molecular formula in questions like this, and you give you percentage composition like this of that compound, what you have to do for questions like this is that you have to firstly find empirical formula, and that's why our topic today is empirical and molecular formula, because there is no way from questions like this, there's no way you will get the molecular formula without first getting the empirical formula. And what's the empirical formula of a compound? Empirical formula is the simplest formula of a compound. It's also the skeletal formula of a particular compound. Do you understand? Just like your skeleton. You know, before your skeleton, before your whole body, you firstly have what we call the skeleton. Without the skeleton, your body cannot exist. So the same thing with this empirical formula. So they ask us in this question to find what the molecular formula. Now, before we can find the molecular formula, the first thing, which is the basic, just like in biology, cell is the basic and the functional unit of life. The same thing here too. The empirical formula is the simplest compound of a compound. Even they may even ask you in your exam that maybe you are doing WAEC or NECO, they may ask you what's the empirical formula. Empirical formula is the simplest formula of a particular compound, that is the smallest, the skeleton of a particular compound. Now, how do you find the empirical formula? Before we are able to find the molecular formula. Now, how do you find your empirical formula? Now, this is it. I'm going to teach you. If you look at what they give us here, let's just follow me. I know maybe you don't know this before, but just follow me. Whenever you want to do a question like this, what you just do is that you look at the compounds they give us, the element they give us. They give us carbon, they give us hydrogen, and they give us oxygen. So now this is what you are going to do. You are going to write each element. You write them like this. Do you understand? Now the next thing you are going to do is you write their percentage, the percentage of each of them. Now what's the percentage of carbon that they give us? They give us 40.0. So let me write this, so you don't need to put percent in front of them again. What's the percentage of hydrogen that they give us? 53.3. What's the percentage of oxygen that they give us? Sorry, the hydrogen is 6.7. 6.7. So that is 6.7. The percentage of oxygen is 53.3. I hope you can see my handwriting. So 53.3. Now the next thing you are going to do is you are going to write this thing that you see that they write here is the molar mass of each element. The molar mass of carbon is 12. The molar mass of hydrogen is 1. The molar mass of oxygen is 16. Do you understand? Now, the next thing you are writing is what? The molar mass of each of the elements. Now, what's the molar mass of carbon? That is 12. Now, what's the molar mass of hydrogen? That is 1. What's the molar mass of oxygen? That is 16. Do you understand? Now, the next thing you are going to do is what we call the mole ratio. The mole what? The mole ratio. Now, what is happening in this mole ratio? What you are going to do in this mole ratio is that you are going to divide 40 by 12. Do you understand? You are going to divide 40 by 12. Do you understand what I'm saying? So you are now going to get something like 40.0 over 12. Because you are just starting, that's why I have to follow this process. So 6.7 over 1. 53.3 over 16. Now you can try to press your calculator. At the end of the day, you're going to get something like 3.3 here, 6.7, 6.7 divided by 1, Of course, you know what that one will be. So 40 divided by 12. So you can see 3.33. So 53.3 divided by 16. So that's also 3.33. So I advise that you make it at times 4 decimal place or 2 decimal place. It depends on what you like, but 2 decimal place is still fair. So we are still under mole ratio. Sorry, we are still under mole ratio. So mole ratio. Now what are we going to get? So I said this is 3.3. So this one is still was 6.7. What's this one? We said it's 3.32. Do you understand? Now the next thing you are going to do is that you are going to divide by the smallest. Divide. Don't forget the step that I taught you. Dividing it. Divide by the smallest. That is, which number is smallest in these three numbers? If you look at it, 3.3 is smallest. So you divide everything by smallest. Do you get the logic now? So you can see this thing is not hard. So what are you doing now? So you'll be doing 3.3 divided by 3.3, 6.7 over 3.33. The same thing here too, 3.33 over 3.33. Do you get? Now, if you do this now, what are you going to get? 1, around 2, then 1, 2. Now, your empirical formula now, how do you now get your empirical formula? Your empirical formula now will now be empirical formula. You can see this thing is not hard. So now what you are going to see, if you look at the carbon, what is the number under carbon? That is what? 1. What is the number under hydrogen? What is that? 2. What is the number under oxygen? That is what? 1. Now, for this type of thing, you don't need this one and this one. You don't really need them. They are not really significant. So, just remove them. It will now be CH2O. So that's your what? Empirical formula. Do you understand? Now, the question is not asking us empirical formula. The question is asking us the molecular formula. Now, if you even look at the option, they already put CH2O there. So that when you do it this one, you firstly think you have gotten it. And some of you will be rushing and you quickly go and pick A. You are wrong. Now, the next thing we want to do is to find the molecular formula. Now, how do you do that? Let me now teach you. So make sure you have written this while watching the video. So let me rub it and let's do that of the molecular formula. I hope you understand the way we did it. So don't be confused with it. So now let's do the molecular formula. Now look at it. Molecular formula. This is how you do your molecular formula. Molecular formula is empirical formula times n. I'm going to explain the reason why it is like this to you. Molecular formula, let me try to write it in full. Molecular formula, if you want to get your molecular formula, is equals to the empirical formula then you multiply it by n. Do you understand? Now this is how you now do it. This is how you now do it. This molecular formula, right? If you look at it, they gave us the molar mass of the whole compound. The molar mass of the whole compound that they gave you here is the molar mass of this molecular formula, not that of empirical formula. Are you confused? They gave us the molar mass of the whole compound to be 180. Do you understand? Do you understand to that aspect? They gave us the formula of the whole, they give us the molecular formula of the whole compound to be 180. Right? So it means in this place of molecular formula, this is your molar mass of the, you can still say this molecular formula, in place of this molecular formula, you can say it is your molar mass of compound. You can now say it is equals to empirical formula times n. You can still say that. Do you understand? So now what's the molar mass of the compound? It is what? 180. Now what's the empirical formula we get? We got this one, right? Now multiply by what? Multiply by n. Do you understand what I did there? I said your molecular formula. No, now for example, this is just like this. Assuming your molecular formula is C3H6O3. I'm not saying that's the answer. I'm just saying assuming that's your molecular formula. This question, they gave us the molar mass of the whole compound. So it means the molar mass of this compound will be around 180. Do you get the logic? So it means in place of molecular formula, I can put the molar mass, because even this one now, you see what I will do for this aspect. I will equate the molar masses of them to replace it. So let me now do it now. So now the next thing you are going to do now is the molar mass of carbon that they gave us here is not for decoration, and hydrogen and oxygen. You now be inputting them for these elements. Each one of them, you'll be inputting them. 180 is equals to, what's your carbon? 12. What is your hydrogen? What's the molar mass of hydrogen? Is 1. So now, if you look at hydrogen, it has a subscript of 2. So it means instead of saying just 1, you will now say 1 times 2. Do you get the logic? Plus, what is oxygen? The molar mass of oxygen is what? 16. No subscript. The subscript is 1. So 16 times 1 is still 1. So what is your, so we are now looking for n. I hope you understand to that aspect. Now, the next thing we are doing is 180 will now be equals to 12 plus 1 times 2, 2 plus 16. So what do we have? We have 180 is equals to 12 plus 2 plus 16. So that is 30. So at the end of the day, you divide both sides by 30. Divide both sides by 30. At the end of the day, what are you going to have? This cancel this. This cancel this. What do you have? 6. This cancel this. What do you have? So our n is equal to 6. You are not done. Look at the question. They did not say find n. You are looking for what? Molecular formula. Now you now come back to this aspect. You come back here. So what is our n? 6, Abby. Now you substitute it for it. I don't want to be jumping step. That's why I'm doing it little by little. So just substitute it. We'll be multiplying it by the subscript. The subscript is here is 1, but it's not written. So 6 times 1, 6. 6 times 2, 12. 6 times 1 here 2. What do you have? 6. Do you understand? So automatically you see your answer. What is the answer like that? The answer is the answer is C. And that's glucose. Although you don't really need to know the name of the compound, but even some of the times you will know that there is glucose. So you can see that's glucose. That's glucose. So our final answer is what? Option C. So whenever you see questions like this, don't run away from this. Of course, we have different aspects of this question, and that's what we are going to be doing in the next video, and on how sometimes they may give you molar mass instead of, they may give you mass of that element instead of giving you percentage composition. It is still this same method that we are going to use. So but in the next video in the next episode that we are going to have on empirical and molecular formula, that's what we are going to be doing. Thank you very much. Bye.